Today we are solving for missing sides of similar triangles. And there's your problem right down there in the bottom left. Technically we can't solve for similar triangles right now until we add these. There, that means that we got parallel lines, so we could technically have corresponding angles be equal, and now we have similar triangles. Now, you might be tempted to look at this and quickly think that you know what x is, but be careful. You might see a pattern like 3 times 3 is 9, so 2 times 3 is 6. X does not equal 6. So we have some steps that we have to do to make sure that you don't think that x equals 6. So the first thing that we have to do is, if needed, separate the triangles. Let's get them separated. Labeling your triangles small and large is optional, but sometimes it helps you get things in the right place. So our next step is to go ahead and label the new side lengths. So these three are the easy ones. Just copy the 2 and the 3 and the 9. The question is, what is that fourth side? And let me tell you some things that it is not. It is not x. It is not 2x. What you need to do is go ahead and add the 2 and the x together, giving you 2 plus x, or we'll go ahead and just write x plus 2. Our last step is to go ahead and set up a proportion and solve it. It turns out there's actually a whole lot of proportions that you can set up that will work and give you the answer. I like to do it the same way each time, and that's by setting it up with a small side over its matching large side is equal to the other small side matching up with its large side. So let's go ahead and do that now. We got 2 over x plus 2 is equal to 3 over 9. So from here, we just got to solve our proportion, which if you're not sure about what I'm doing with this, watch my video on solving proportions. So we got to get the bottoms the same, but before I do that, just to make this problem a lot easier, I'm going to take a look at 3 over 9 and simplify that to 1/3. So now I need, on the left side, I need a 3, and on the right side, I need an x plus 2 on the bottom. So bottoms are the same, and now I can just write what I have on top. 3 times 2 is 6, and 1 times the x plus 2 gives us just x plus 2. Go ahead and subtract 2 from both sides, and 4 is x. So our answer for x is 4. Next problem. Alright, this time to get similar triangles, we've got alternate interior angles that are equal. And you definitely want to carefully mark these because this is going to help you match up the sides correctly. So you can mark the small and large triangles if you want to. So now the question is, what does the 12 match up with on the small triangle? Does it match up with the x or the 18? So notice that the 12 is next to angle 1 on the top. And on the bottom next to angle 1 is the 18. So I'm going to highlight those. So now I know 12 matches up with the 18, and then the 10 would match up with the x. Now I'm ready to go ahead and set up my proportion. Small over large equals small over large. So 12 over 18 equals 10 over x. Alright, to get the bottoms the same, I'll multiply the left side by x over x, and the right side by 18 over 18. So the denominators are the same, and that leaves us with 12x equals 180. And divide both sides by 12, so x is 180 over 12. I know I can divide those by 6, which gives me 30 over 2, and then I can reduce that to 15. It turns out that this problem would have been a lot easier if I'd done a different first step. So look back, and do you spot what I could have done at the start of this problem that makes everything easier? Here it is. Reducing at the start of a problem is almost always your best strategy. So if I divide 12 and 18 by 6, I get 2 over 3. Now I just need to multiply the left side by x, the right side by 3. Now I'm left with 2x equals 30, and go straight to x equals 15. Next up are your practice problems, so be sure to pause the video when you see the problem, work it out on some scratch paper, and then hit play to go ahead and check your answer. Alright, vertical angles gives you similar triangles. You can mark small and large if you want. The 15 matches the 18, so you can make your proportion. Always best to reduce, and there's your answer. So this problem is actually a little harder than any of the ones we've done so far. You have to actually solve for x and y. It's all the same procedure, but it's going to actually take one proportion to solve for x and a different proportion to solve for y. Go ahead and give it a try. Separate triangles, mark the small one, mark the large one, making sure that you added the 3 and the 4. Some extra highlightings can help you make sure you get the right sides matching up when you make your proportion. Just multiply the right by 2 and you get your answer for x. Now y takes a different proportion, and this time you multiply by 7 and y, and you get 42 equals 4y, so that can be 42 over 4, 21 halves, or you could have called that 10.5 as a decimal. Last problem. Go ahead and pause and give it a try. Separate your triangles and label the small one, add to label the large one, and now you got to be careful. You got to find the side that has just numbers, no variables, and you're going to use that in both of the proportions that you write. So we'll do some markings, and we're going to solve for x first. So 10 over 24 equals x over x plus 20. We got to get the bottoms the same. And then there's so much going on, I went ahead and highlighted what's left. And there's our equation, and then we just solve that equation. And you can write your answer any way you want, 100/7 or 14 and 2/7, or if you want to do a decimal, just go to 3 decimal places, so 14.286. Now, I didn't have any more room to solve for y, so I'll go ahead and erase this and show you the solution for y. There's our proportion that we'll use to solve for y, and putting parentheses is a good idea, as well as reducing. Now we'll get the bottoms the same. I'll highlight what's left, and so there's my equation that I get, and there's my solution.